Welcome, everyone. Welcome to the Azure Virtual Machines Deep Dive session. I'm Mahesh Tyagarajan. I'm a program manager in the Azure Compute team. I've been with Azure for about 2 years now, and I've been working on the new compute stack that is being introduced under Resource Manager today. So we'll be spending a lot of time talking about it. Before we go deep, I just wanted to kind of get a quick check on how many of you know about Resource Manager, have heard about it, have listened to talks about it. 30–40%. So that's good. So because this is the reason I asked was this is a 400 level session. We're going to go deep dive. Talk a lot more about the compute advancements that we have made. So it does expect a little bit of understanding of what Azure Virtual Machines is. I hope most of you who are new to virtual machines have listened to the introduction to IaaS session. So this talk will be a little bit more high level. So let me do you want to introduce yourself?
So hi, my name is Boris Scholl. I'm a program manager on the Cloud Platform Tools team. My team looks after everything related to tooling for what we say hyperscale or large-scale compute. So Azure, virtual machines, service fabric, IoT scenarios, everything that goes big.
All right, cool. So mandatory slide. Do give us feedback. We'd love to hear feedback from you so we can tailor the sessions accordingly and make it better. All right. So what are we covering today? We're going to focus heavily on the IaaS v2 stack. For folks who are not aware, at Build we announced the introduction of the new compute model, compute APIs under Resource Manager. We've termed this IaaS v2, and we're going to cover a lot about IaaS v2 in today's session. The second part of it, we're going to focus a little bit on how we are improving the dev and test story even further by the integration of compute, network, and storage stack under Resource Manager. We'll be going deep dive into some of the templating model. We'll actually show some cool demos around SharePoint and things like that. Then we'll focus a little bit on how to actually deploy complex applications on IaaS. We'll pick up a sample. We'll walk through how to build a complex template and actually go ahead and deploy it. And in the end, we'll talk a little bit about the single unified Azure stack for the compute cloud. You might have heard some announcements at the keynote or the foundation session. So we'll talk a little bit about that, show something that you have not seen before. All right. Given the fact that there's 30–40% of people who've kind of heard about resource groups, I'm just going to spend a couple of minutes introducing the concepts for folks who have not heard about it. Resource groups or Resource Manager is a new service that has been released in Azure. It has been around for about a year now. We've had support for SQL databases, websites, and a bunch of other resource providers. But compute, network, and storage announcement happens today, happens with the build announcement. And so I'm going to talk about some basic concepts here. Resource groups, think of them as a logical container, which allows you to place a set of resources together in a resource group. Think of an application. You could think of an application like, say, MongoDB, or like a 3-tier app like SharePoint, for example. You can choose to place different tiers of those applications in specific resource groups. For example, you can say, hey, I want my front-end tier in a resource group. I want my SQL tier in a separate resource group, and a database tier in a different resource. You can choose to do that. But the idea behind resource group is that we provide capabilities on the platform which allows you to manage the entity as a whole. A good example would be in a dev and test scenario. If you actually have a single app deployed, you can choose to delete the entire resource group as a whole, which is a big advantage, right? Typically, if you think about scenarios where you're doing large-scale applications, you have 100 nodes that you're spinning up and spinning down. Management of those nodes are pretty hard. So resource groups allows you the flexibility to either delete the entire set of nodes as a single go, right? You make a single call to delete the resource group, and we take care of deleting all the entities underneath it. Now, when would I want to use resource groups or think about it? Think about 4 properties. Think about the life cycle of the resources. How do I want my app to look like? Do I want to place my tier in a separate entity, or do I want to place all tiers in a single resource group? It's up to you. You can choose, but keep in mind the life cycle aspect of it. The second is tagging or billing. Think about how you want to tag the resources, because what we've enabled is the capability where you can now get the tags that are configured on the resource is propagated to the bill. So any tag that you configure, for example, like say, application is equal to MongoDB, for example, that tag will not just stay in a UI level or for querying. It'll actually propagate through and be available at the end in your customer bill at the end of the month in your CSV file. So with that, you can actually go build rich pivot charts to say how much did each department cost. So billing is a key aspect of how you architect your resource groups or how you place the resources in a resource group. Another aspect of it is role-based access control. Think about how who gets access to a particular resources. For example, if you have a database tier, you want to actually give access or write access only to the database admin. If you have a virtual network and a set of networking properties, you want to give only the network admin the right access to it. Everybody else can get read access, but you want to just place, give write access to the others. So think about these different aspects when you are creating a resource group and placing them in different entities. The last one here is if you were thinking about high availability or DR scenarios, a resource group actually spans regions. So if you actually have a MongoDB which has the primary sitting in, let's say, West US, but the secondaries are sitting in a different region, you can choose to actually place all of that in a single resource group because the resource group spans the entire globe that Azure regions that it supports. So keep that in mind. Okay, so the key aspects are should the resources be in the same resource group or not? You should always think about the common lifecycle, the patterns, the billing aspects of it, and then architect your application accordingly. And we don't support this for now, but we will add support in the future where even if you make a mistake of actually placing a set of resources in a specific resource group and you're like, hey, I want to move this to a different entity because that's where the lifecycle matches better, we will support APIs where you can actually move resources between resource groups in the future to make your management better. Okay. The next aspect is, you guys have heard a lot about it. I'm going to spend a brief amount of time here. I'm going to introduce templates. Template support has existed in the platform for about a year now. I'm not going to go deep into it, but I do want to talk about some of the advantages that it offers when in context of compute. Right? Previously, we just had websites and databases, but with the introduction of compute, it opens up an entire gamut of applications that you can now go build and architect on Azure. And the inherent capabilities that template language provides is actually very helpful because templates themselves are idempotent. Just by saying that templates are idempotent, we also mean that the APIs that are backed by the templates are also idempotent. For example, if you actually have a virtual machine and then you create it with a couple of data disks and you actually do a get VM and then post it back to Azure, it is actually going to accept that request and continue to process it and say it's going to give you a success immediately. So all the APIs going forward that are supported under Azure Resource Manager for compute is idempotent. Compute, network, and storage are all idempotent. And the template language offers this orchestration capability. So when I talk about orchestration, it is the capability where you can actually define a set of resources to be dependent on each other. Say, I want to spin up, in the case of AD, an Active Directory setup, you want to have the primary that boot up first and actually be ready before you want to start up your secondary. So you can actually express the dependency to say, VM2 depends on VM1 before it can actually start up. So you actually express the dependency at the infrastructure layer. And with resource groups and resource manager, you also get the flexibility of just trashing an entire resource group when you're doing dev and test. So we don't offer a rollback capability per se, but it simplifies your rollback mechanism where you just start with a deployment, you push something to a resource group, and then you see, hey, like step 3 of the whole deployment just failed. Instead of just trying to fix that and go and muck around with it, you can just say delete that resource group and start one from scratch. So it's actually pretty easy to do that management. And as I said earlier, with the integration of compute, network, and storage, it coupling itself with Redis cache or SQL databases or website, it opens an entire gamut of applications for you. Now you can orchestrate or build an application or a template which contains all of the Azure resources under Azure Resource Manager with a compute offering. So it gives you a lot more flexibility. We view template files as source files that are checked in, managed, maintained, and used by you guys, and it's stored on your side. And it is continuously used for deployment purposes into Azure. And the parameterization capability in the template itself makes it repeatable. So if you actually have, let's say a SharePoint farm and you're doing some dev and tasks, if you actually go architect one template, you can reuse the template again and again for rebuilding your app again and again. So it becomes very repeatable, very easy. In the previous cases, you had to go write your own shell scripts or CLI scripts or PowerShell scripts to go build your app on Azure using compute. This simplifies that drastically. So dev and test becomes fundamentally simplified. Okay, so just to kind of touch on some of the, the big improvements here. Complexity is made simple, and I'll show you some samples about the complex applications that we've gone ahead and built on Azure. Now you can blend and build applications using IaaS and different PaaS services that are available in the platform. When I talked about PaaS services, SQL or websites, I'll dive deep into some of the scalability aspects of the new virtual machines and the improvements that we have made here. So now you would be able to spin up, hundreds of VMs really really parallelly. And the integration of role-based access control on tags, offers a great flexibility for enterprise and dev and test scenarios, which we will dive into. And what you're seeing there on the right-hand side is a new community template section that we have launched with Azure. This is going to contain about 60 to 70 odd templates, which are, some of them are basic starter templates that lets you get started. We also have a lot of complex application templates, and we'll be going a little bit deep into that towards the end of the session. Okay, so what are the biggest advantages that are being offered when it comes to the new compute stack? The first one really is the massive and parallel deployment of virtual machines. One of the common pain points that used to exist with XML-based APIs that supported on the platform was we were not able to process, or the Azure stack would not process simultaneous deployment of virtual machines, which you would have faced most oftenly. And that's a massive improvement in the stack. Now you can actually go ask for, let's say, 20 VMs in an availability set if you want, and we will go process all of those 20 requests in parallel. So that's a big difference than what we used to do before. The second aspect of it is the platform offered the concept of availability sets, where we actually physically placed your virtual machines. When you say 2 VMs are in an availability set, we physically placed the VMs in 2 separate racks, 2 fault domains as we called it. This ensured that you had high availability from the platform when the platform rolls out upgrades. Now, with the introduction of the new compute APIs, we are increasing that to 3 fault domains. So for applications that require, like quorum-based workloads, now you can actually get and ensure that the platform will not take the third, will only take 1 VM down in the 3 VMs at any given time. So this ensures that you always have quorum to make sure that you don't these VMs don't go down when there's a physical fault failure. And we've made lots of improvements around the VM extension capabilities as well to make it work well with the templates, and we'll be doing a deep dive on that. We've made a lot of changes around SSH keys and how things are done. You don't have to use a certificate anymore. You just have to, you can directly push the SSH2 RSA format for the certificates going forward. And premium storage support was announced on the XML-based APIs 2 weeks ago. With this announcement, we also are introducing the premium storage support on top of the JSON-based APIs around Azure Resource Manager. Okay, now I want to spend a little bit of time talking about VM extensions. How many of you know about Azure VM extensions? A decent number. Okay, so I have to spend a little bit more time. Okay, so Azure VM extensions are, so with IaaS virtual machines, what you get is the capability of getting just the infrastructure in the cloud. But that's not all of it, right? There's just a lot of work, a lot of in-VM configuration that you need to do to actually go get your app up and running inside the virtual machine. So we've partnered with a lot of, third-party vendors who've actually, and we have some folks from Docker sitting right in front. We have the Docker extension also on the platform. We have partnered with a lot of the third-party vendors to actually go get the extensions like Chef and Puppet into the platform to make it easy for customers to do in-VM configuration on the infrastructure. In addition to third-party tools like Chef and Puppet and Docker, we've also focused on getting the basic scripting capability. So we have custom script Windows, we have custom script Linux extensions. So you can actually write a shell script or a Python script and ask for it to be run inside the virtual machine in a very easy fashion, both on Windows and Linux. And we also have first-class DSC support. This is the desired state configurator support from PowerShell. We also have first-class support for that in our extension model. So the way it works is that the extensions are curated first-party models or agents, if you will, that are being published to the platform, and we replicate them all over the world. So whenever a virtual machine is created on Azure, and you say, hey, I want to push a DSC agent into the platform, we actually take that agent from one of our globally replicated stores and push that agent inside the box. And then the platform is in constant communication with that agent to be able to give it instructions. In one case, you can say, hey, go run the script, right? We actually take that script and actually send that instructions down to the agent to be able to go do that work, so it actually happens inside the VM. And the power of this with Resource Manager really is now where you can express dependencies between these script files as well. So you can actually say, I have 2 VMs and I want to run 2 scripts between them, but you can express a dependency where script 2 on VM2 can take a dependency on script 1 on VM1. So you have in-VM configuration and dependencies that you can not just express on the infrastructure layer, but now you're expressing dependencies between the script files that you're running across the different VMs. Now, in-VM configuration of this just becomes really simple. So now you can express dependencies not just at the infrastructure layer. Now you're expressing dependencies across the application layer between the different environments, and you are building complex applications on Azure. Right. Another key part about the new compute network and storage stack, or the changes that we have done, is also gone ahead and fundamentally looked at how do we want to expose networking to customers? How do we want to expose the bare bones networking constructs to customers? So the first thing that we have done is that earlier you used to have the virtual machines would carry the networking configuration, like, you know, I want a reserved IP, or I want an endpoint for the VM. All of the networking configuration was part of the virtual machine itself. Now we have broken that apart. We've really taken the Lego blocks of networking and just started provisioning them. So going forward, you'll have a network interface as a first-class object to be able to attach to a virtual machine. So that's the first thing that you create. And the important part about the network interface here is that it's not, it is a floating network interface. So when you actually delete the VM, it's actually not going to get deleted. So the life cycle of the networking configuration is actually separate from the virtual machine itself. And the good part about this is when you do complex application configuration, like, you know, I want to use security group A and then put it in virtual network B, all of that configuration just stays with the virtual with the network interface and including the IP address. So you can actually float the network interfaces around to the different virtual machines that you need. And load balancers, this is one of the things that you used to offer as an implicit capability in the old model. Load balancers is now a first-class resource that allows you to define a load balancer, internal or public, and then attach the NICs to the load balancer and say, hey, here are the NICs that I want to load balance as part of this load balancer. So you get the flexibility of doing that. And another improvement that we've made is around the virtual networking APIs. So if you think about the existing model, we used to have a NetCFG-based model where it was XML-driven. And if you had, let's say, 10 virtual networks in your subscription, you had to toggle and operate using that single XML file and actually toggle all the 10 virtual networks in the stack. With the improvements here, now you get the flexibility of dealing with and operating only for a single virtual network. And we have also added support for toggling individual virtual networks through PowerShell and cross-plat CLI commands as well, so which is very flexible. And we've also added support for public IP addresses. We had support for this on the old stack as well, but we've also added in the V2 stack. Public IP addresses can be dynamic or static, and it can be assigned either to a NIC or to a load balancer. The last one here is the network security groups. Network security groups offers both inbound and outbound rules, so you can actually go filter based on, hey, you know, here are the inbound rules that I want to set on my public IP address, or you can actually configure outbound rules or inbound rules as well. Okay, so what are the notable changes in the APIs? There are a few things that we have fundamentally changed. We used to have something called as a cloud service, which offered a lot of these capabilities. That's been modified to us Lego blocks, really. So the cloud service that it offered used to offer us a public IP address or a VIP. It used to give us an implicit load balancer. It used to give us an implicit concept called an availability set. The networking configuration was tied to the virtual machines. All of those constructs were so tightly coupled with the virtual machine and the object itself. We've really broken them apart, given them the Lego blocks, if you will, and actually asked you guys to construct and actually make them stitch together the way that you think is the right way to go about it. And we have a lot of samples to make it easy for you to understand how this can be done. And these samples include not just at the template level, but also includes, goes from templates to PowerShell commandlets to CLI support, and including client libraries. We added support and samples for all of these different entities, so you can actually go do that. Another key part that I do want to mention here is that going forward in the Azure stack, virtual machines need to be created in a virtual network. You cannot create a virtual machine just by itself. It has to be placed in a virtual network. This is security by default. We want to make sure that every virtual network, every VM created on Azure is in a virtual network. And you have to explicitly choose to say that you want to place the VM on the internet. If you create a VM by itself, it's not going to get a public IP address like before. So it gets secured by default. And you have to ask for a public IP address, and then you can float these IP addresses that you want. So this is a big difference in what we're doing here. And no more implicit DNS names. You used to get something like something.cloudup.net. If you don't want it, you're like, hey, I don't care about it. It was just, added. We don't provide that anymore. If you want a DNS name for your app, you need to ask for it. You need to put it in your public IP address. So if you've gone back to the basics of just saying, how do we introduce networking? How do we do networking as the basic building blocks? And that's what we've solved with the new APIs. Okay, so with that, I'm going to hand off to Boris and talk a little bit about how we've simplified dev and test on Azure.
Yeah. So how many of you use Azure IaaS for dev and test scenarios? Okay, cool. How many of you have actually done a SharePoint deployment before? A lot of people. Okay, the reason why I bring that up, like in the Microsoft world, one of the complexest deployments or topologies was in fact SharePoint on-prem. And this is what we're going to show, or what I'm going to show you today, how simple it is. So why do we think like the new virtual machine stack or a new Azure stack has drastically simplified Azure usage for dev tests? So first of all, when you build or back in the old days, so I like to call it, when you spun up your environments in Azure, you probably wrote tons of PowerShell scripts because you want to have an automated and repeatable workflow. The problem with PowerShell scripts, at least my experience of what we heard from customers is, even though you share them, if you want to do another environment that's exactly like that, the one that you spun up, you run into issues more often than not. You need to debug it, you need to figure out what's not working and things like that. So it's really cumbersome to share like those PowerShell scripts with the configuration. So with Azure Resource Manager, because we have a declarative way of describing an environment, it's really nice and easy to repeat the deployments over and over again. Another important aspect, and that's another big difference, Mahesh mentioned that Azure Resource Manager is idempotent. That means, like, think about the PowerShell scripts that you had to write. You wanted to create a resource, and you wanted to create it again, so you had to check if the resource was there and things like that. So it was all an effort to put that code in there to check if the resource was there, and you needed to catch it, and then you needed to handle that situation. So with Azure Resource Manager being idempotent, it's already built in. So you can think about you have a template that defines your environment, you publish it or you deploy it once, your environment is there. Now you're going to repeat this deployment and you just make one change. Let's say you add another server to it. Azure Resource Manager will only add that additional server to it. So that the succeeding deployments are really fast because only the changes are being impacted by the next deployment. That's really great. So another advantage of having everything in one template is you basically can manage the entire application as an entity. Before you had like, I remember when I built like PowerShell scripts for PowerShell environments, we had tons of scripts, we had a master script and things like that, so it was really hard to keep track of. Here with the template approach, you really have everything in one template and you can manage it, you can source control it. You can even track, like, once it's source controlled, who made changes. So you can really ensure that everything, the entire application is managed as an entity. The other aspect, I work on the Visual Studio side. For us, the way we think about it is config as code. So obviously, like a template, because it's just a JSON file, it can be easily integrated in our like lifecycle tooling, like continuous build and delivery pipeline, release manager, and the dev test lab that we have announced yesterday. So once you define your environment as a template, it plugs easily into our stack. And if you don't use our stack, it's also good because you can just use CLI, PowerShell, or any scripting language just to deploy the template. Another advantage is really easy monitoring and alerting, because with ISV2 you get you get a little bit more capabilities when it comes to monitoring and alerting. So as Mahesh described, there is this notion of extensions, and it's called Azure Diagnostics Extension, which is basically an agent that runs on the VMs, collects data about the machine or the application that runs on top of it. So you get that for free, it's easily to integrate it, and then your application or your environment is being monitored. And obviously you can also hook it into our alerting system. Another example or why this is drastically simplified, how many of you run a dev test environment in Azure but need to connect it back to on-prem, for example, to get certain data? So with that, we also make sure you have a good hybrid connectivity. What we think you can use a point-to-site connection, side-to-side, or express route. So it's really easy now. With that, because we talked a lot, let's do the first demo. And back to here. Okay. Can everybody see that okay? All right, so what I have here is Visual Studio, but it's not a Visual Studio code project whatsoever. It's really just a template here. It's called deployment template.json. And you can think about this template describes a very complex SharePoint farm. It has like a SharePoint front end, it has a SharePoint app server, and it has a database layer. So think about it, it could be any topology like that, very sophisticated topology. Of course, I want to follow a golden rule, so I don't want to start everything from scratch, because if I needed to build that template from scratch, it would take me forever, and it was probably like really hard to do. So Mahesh pointed out that we have that GitHub or the Azure Marketplace with all those templates. So you can go there, grab a template that meets your needs, use it, put it in Visual Studio, and customize it. Or someone in your company might already have defined an environment in a JSON template, and you just enlist to the source or to the repo, open it, and then you can start customizing it. So as I mentioned, what I have here is a JSON template, and I don't want to dive into the tooling here, but the nice thing about it is, because it's a very complex template, is we have a so-called JSON outline view. So we don't want to build a designer or anything like that. We just want to give you an idea, hey, what resources, what parameters are being used by the template, and make it really easy for you to customize it. So in here, if I look at the resources, I see I got quite a bunch here. It's like all my variables and my virtual machines and things like that. And if I wanted to add something to a resource, I could do that by just clicking Add New Resource, and then I could bring up the Add New Resource dialog. It basically, what it holds is a bunch of JSON snippets. And that didn't work. So what it holds is a bunch of JSON snippets that define artifacts in your environment. So for example, you could add another virtual machine to it, or another extension, or another network. So as I mentioned before, I already deployed the template to Azure, just to prove it. It's here. It's basically a SharePoint farm on Azure deployed through Visual Studio. So what I'm going to do now is, oh, now it's here. Look at this. This is the template. That's the snippet editor. OK. What I want to do now is I want to show you the item potency. And what I've done here is I created a very simple load test that basically hammers the SharePoint website. And because I haven't changed anything on my front end, I'm going to start deploying the template. And you should see when we're in the portal that it's still accepting requests. Let's do this. Let's run the test. The load test is actually using Visual Studio load testing service. It's also cloud-based, so I'm not executing it locally because my machine wouldn't be, or doesn't have the horsepower to hold all those agents, right? It's very easy to integrate. Only downside is it now needs to require some resources, so it will take a while, but should be fairly easy. And while it's configuring the agents, while we start that, I'm going to go and deploy the template. So in here, this is the deploy to resource group. So there is no, and again, there is no Visual Studio magic, because what we use to deploy the template is really PowerShell. It's a PowerShell script that you can just use, take, customize, so it's what every IT pro uses. So there is no magic in Visual Studio whatsoever. So in here, I'm going to choose my subscription. I already have my resource group. And then I just want to show you the parameters, because you've seen on the left-hand side in the JSON outline view, I had quite a bunch of parameters. But this is fairly convenient, because it gives you the parameter name, and you just need to add what you want to name the resources, right? So let's save it, and then kick off the deploy. And this is a little bug. So now the deployment started. And if we look down here, if everything goes well, which we hope, it has a template, is valid, so it's been validated by Azure Resource Manager. Everything is good in a template. Then it starts creating the template deployment. And then you should see any minute that the resource creation is fairly quick. you need to think about this is like virtual machines, virtual networks, and everything. But this is really the idempotency. It really goes in there and says, OK, I already have that. I haven't touched it. Nothing has changed. And it basically just goes to the next step. Here it starts and says availability set, storage accounts, succeeded. So let's do one thing here. As you can see, like now it's really start going, right? Hey, I already have the resource. Resource hasn't changed. Go to the next one. Go to the next one. And while it's doing that, if we go in here, that's the Server Explorer. I can go to the SharePoint front end, click on Configure, which takes me to the portal. It deep links into the portal. We don't want to have any configuration stuff in Visual Studio because we really think the portal or PowerShell is the right way to do that. So we're going to take it to the portal here. And then you can see your SharePoint virtual machine is still running while a new deployment is going. And that's, I think, is really great, especially for dev test scenarios. All right, with that, I'm going to switch back to slides. But I think because most of you have already heard or seen about, where's that? About tags, and Mahesh already mentioned it. I just want to point out a couple other things because the tagging, when you think about tagging, it's name-value pairs that you can assign to resources or resource groups. So in a dev test scenario, that's pretty convenient because, as Mahesh mentioned, you can actually tag environments and say, this is my dev environment, that's my test environment. But there are other scenarios that I want to point out because there is like, you get a pretty decent insight in your costing, right? Because you can also tag by department. You could say, hey, those resources are being used by the finance department. Those resources are being used by the engineering department. And then in your billing, you just need to filter out those tags, and you have a granular bill. The reason why I'm mentioning that is because we also got a lot of complaints about our billing system, and it was hard to figure out who uses what resources. Another thing, what the tagging is good for, you could actually tag Ryan Jones, who works on the Azure Resource Manager, had a very good example. I just repeat that. You could actually tag a resource with the responsible person for that resource. So think about you have a mission-critical application, something goes wrong, and you could actually just go to the tag and say, who should I contact here? So those are just a couple of high-level samples why this is great. The next thing I just want to briefly touch on is resource-based access control. So I'm doing a lot of EBCs in Redmond up there about dev test in Azure, and the very first question that we get, okay, how do I handle my subscription management? Because how should I do this with developers, with my departments, and so on and so forth? And so far, you could only do it like on a subscription level. And you had to add like other people in your department to the subscription, or each developer had its own subscription. So with RBAC, you really have a granular permission control of your resources. So you can basically say, I want to think about a multi-layered application. I only want to give a certain group of people access to my app servers. I just want to give a certain set of people access to my web front-end servers. And it goes even that far that you could say, I want to give them access to, or I want to give them permission to certain actions. So for example, I could say, OK, I'm going to trust Mahesh to access my machine so he can remote desktop into it, but I won't let him shut it down because I need it for a demo. So this is coming. I think we're going to announce that soon.
Yep.
Right? So overall, I think RBAC is a great way of controlling access to your resources. And we got that feedback from you over and over again, and there it is. So I think it's really good. I just want to skip over those 2 slides here because I'm going to switch back to the demo, like deep dive.
All right, cool. So I think that was a good introduction about how we can continue to use, do dev and test on Azure, using templates and the new APIs. What I'm going to focus a little bit on is the update and upgrade story. When with the announcement of APIs and template support, now you have two models in which you can actually go deploy virtual machines. You can actually say, hey, I'm going to define it using a template. Here's my app, and you can go deploy that. Or you can use the old model the way you guys have done before, is to say, I'm going to author my own custom PowerShell script that is going to create, using new Azure VM, for example. So we will continue to support both models. The support for templates is really all about the ability where it makes it easy for you to deploy an application. Now, so we talked a lot about first-time deployment. Now, when you think about upgrade or update story, you have the flexibility to do whatever you want. You can choose to say, my deployment model and my management model with Azure going forward is going to be all about templates, because the templates are idempotent. All that you can do is you can actually go deploy an app and say, 2 months later, you come back and say, hey, my web front-end performance is not that great, so I'm actually going to add a cache tier. And you want to bring a cache tier with a couple of more VMs, for example. You can just take the same template file, go modify the template file to say, add a couple of more VMs, and just deploy it again. So your update and upgrade story can still be used or done using the same template file. Or you could completely say, hey, I'm just going to use this for my first-time deployments. I'm going to use this template. But after the first-time deployment is done, all my maintenance and management and further updates, like I want to add a data disk or I want to change the IP address, all of that can be done using your existing tools. You can continue to use PowerShell. You can continue to use the CLI tools, and that's absolutely up to you. So all that we've opened up is another layer or a model that makes it the job simplified. But at the end of the day, you get the tools that used to exist before to continue to manage your virtual machines the same way like you did before. Okay, now the manageability and the debugging story is interesting as well, because now you're triggering a template deployment that's going to run for let's say, half an hour, 1 hour, right? So the debugging aspects of it is actually very, very critical, because let's say you failed at the 50th minute and your entire app is dead. So it's not very useful. So we have added support at multiple levels. We have support in the PowerShell tooling. We have support in the Explat CLI tooling. We have support in the portal for you to exactly see what happened to a template deployment. Let's say you had 10 resources that you're spinning up. You can actually go exactly look at when was the 7th resource that was spun up, what was the error message. You can actually have a rich filter that shows you what happened. We also support auditing, like any other, like we used to do before, auditing on all of these operations. So we store the data for about 90 days. So you can actually look at what happened during this time. And another key part here that I do want to touch on is when you use resource groups and actually have a bunch of resources. In some cases, you have HPA data, like a storage account could contain a lot of information, which is very, very helpful. Accidental deletion of a resource group means that accidental deletion of data. So we support the capability of management locks. So you can actually go into a resource group and lock certain resources that doesn't have to be deleted. So you can actually protect those resources from being deleted. So when you actually try to delete the resource group, all the other resources will go away, but the ones that you had the management locks on will not be, and the resource group will be stuck. It'll throw a failure, but looking at the logs, you'll be able to figure out saying, oh, I've expressed a management lock on a resource to ensure it doesn't get accidentally deleted. So it is powerful. At the same time, you can make mistakes. So we've provided the capabilities where you can go use the management locks capability there. And we've also added support for resources.azure.com. Today in this session, I'm not going to go dive deep into it, but do note that link. That's a tree structure view of the entire subscription. So you can actually go look at just the data. Like it would just execute the get calls on all the resources and list you the tree structure view. It's a very, very helpful, very powerful tool, especially if you're using VM extensions. You can, when you're authoring or developing scripts, you can quickly look at what happened to the output of my script. You don't have to go to PowerShell. You don't have to go to CLI. You can just run a template, quickly go to resources.azure.com, look at the VM, and see what went wrong on the particular script execution. So it's very powerful from that standpoint. Okay. So let me switch here to a quick demo. 8. All right. Everybody able to see okay? Is the font okay? All right. So what I have here is Visual Studio Code. What I'm doing here is I have a deployment, which is, think of it as a scalable web tier. I have a set of VMs that I've deployed as the front end. Now, I'm going to showcase an example where it is how we have simplified the ability where you can now scale that web tier in a very simple fashion. So in this sample, we're looking at a template which has the parameters section. So the template itself contains 4 important sections. The first is the parameters. Parameters make the template repeatable. The more you parameterize, the more options you have, or the flexibility that you have to repeatably deploy that again and again. The second section is the variable section, mostly runtime constants that you can assign. The third section is really the resources section. The resources are the set of resources that you're spinning up for your app. Last one is outputs. Outputs are used for looking at whether a certain operation was successful or not. So in this case, I'm obviously accepting the admin username password as an input, storage account as an input, and etc. But the important part that I want you guys to note here is I'm accepting a value called number of instances in this template. The number of instances here, I just said, hey, I want to go spin up 2 VMs. So that's important. Now, after the instances are specified, in the resources section that I'm spinning up a storage account where my disks will be placed. I'm creating a virtual network where my VMs will be placed. Now let's look at the public IP addresses. So in this section, I want you guys to focus on this aspect. So what we have here is a new capability called copy capability inside the template language. So what this offers is the capability where you can place this in a template file and actually ask it to be executed n number of times. So in the case where I accepted it as 2, what this is going to do is it's actually going to create 2 public IP addresses simultaneously because there are no dependencies. And I can also use the capability called copy index, which allows me to name the resources correctly. So in this case, what happens is the resource will be named public IP 0, public IP 1, and start creating that resource. The good part is I can now extend the copy index capability to other resources as well. So I actually have the same thing here for network interface, and I'm saying here's the NIC loop, and I'm creating 2 network interfaces because I want to go attach it to 2 virtual machines. So you can continue to extrapolate that, and then it keeps applying itself. Now, another important part here is that I can also express dependencies between the n number of resources that I'm creating. So I created 2 public IP addresses and 2 NICs. I can also express a dependency that says my NIC 0 actually depends on public IP 0. So implicitly, without actually having to go ahead and declare all of these instances again and again, you have the capability to just implicitly specify here's the dependency. So public NIC 0 depends on public IP 0 being available. NIC 1 depends on public IP 1 being available. So you can express that dependency right here. And the same applies for virtual machines. I go and extend that, and I use that capability all over. Now, what I have here is that I've already gone ahead and deployed this template with a couple of VMs. So I'm just going to go ahead and quickly show that. So if you see this, I actually have a couple of VMs here, my VM 0 and my VM 1 with a couple of NICs and IPs. Can also look at the scalable web tier here, and there are a couple of instances of virtual machines sitting here. What I'm going to do is now I'm going to quickly modify. I have a parameters file for this template. I'm going to quickly modify this to say 20. So the simple click of changing this number, I'm going to go ahead and now start to deploy this whole thing. So I'm doing a new Azure resource group deployment into the scalable web tier resource group. I'm giving the path of the parameter file that I just modified, and then the path to the template file. The template file was the same template file that I used before. Let me just go make sure this is saved. Okay, cool. All right. All right, so these templates are posted onto Azure Resource Manager. The template is valid, and the deployment is now being created. In this case, what happens is that now it's going to look at, oh wait, VM 1 and VM 2 are already up and running, and the user is asking for 20 more VMs. So we'll automatically start provisioning the remaining 18 VMs just based on this template. So it shows the idempotency nature in the template. It also shows the scalable nature of the stack. So as you can see, slowly the IP addresses will start getting created. The network interfaces that are dependent on them will start getting created. So, and this is a key part, not just purely from a deployment standpoint, but also the fact that the scalability of the stack, right? Previously, if you wanted to go do this against the XML-based APIs, you would have to wait a couple of minutes before you go to the next operation. You would not be able to add the VMs. But the improvement here really is around how we've fundamentally simplified the ability to go do this first at the language level, where in a template you can just do this by a single change in a number. And also the underlying platform has significantly improved to provide the rich capability for scaling up really fast, right? Okay. And you can see these VMs are going to continue to run. In shortness of time, I'm going to jump back in again to the slide deck. All right. So the next part, we're going to focus on how do we go about deploying complex applications. Now we just looked at a simple app that just was a front end. I had a website running there. I just scaled it up. It was not that big a deal. Sure, we could do this using a PowerShell script, but we simplified this using Resource Manager. But how do we fundamentally simplify complex, right? So one of the things that we've heard about, you must have heard about it before, but we have support for a lot of the Windows and Linux workloads on the platform. But the key part, and we have the tooling support, we have the NVM configuration support. But the important part here is now the work that we have done for application templates. If you look at the bottommost part of it, those are all the different apps that we have templates for already. MongoDB, or integration with Docker containers and actually go deploying an app. Django or Cloudera data stacks. So we have real-world production application templates that are available right now for you guys to go and try out, right? Previously, if you had to go do this by yourself, and if you want to go architect this application, it would have taken you like a couple of weeks to just know what you need to do, understand the different constructs. But now what we've done is we've simplified the ability where these application templates are available for you to go start from. You can actually just start from a Kafka cluster. You can go look at, oh, here's how I spin up a DataStax Cassandra cluster. You can take that template back, go make the necessary modifications that you want, and then go deploy it again. So you get that flexibility from the platform. And the next part is when you think about architecting templates. So in this section, what I'm going to do is I'm going to give you guys a little bit more insight into what you need to think about when deploying or architecting templates for your complex applications. Just first of all, just think of them and break them down into infrastructure and NVM configuration pieces. When you break them down into infrastructure, think of them as, hey, what am I architecting the template for? Am I architecting this just for a single production environment, or am I architecting this for multiple environments? So think about, am I doing this for like a dev environment, test environment, or prod environment? What are my different requirements? How many VMs do I need to place in each one of these different environments if I were to use the same template again and again? And then for common application infrastructure tiers, I'm going to show you a sample. It would be a good idea to break them apart. Like if you're creating a single virtual network where the entire thing is going to be deployed, I would recommend that you actually create a separate template just for the infrastructure pieces, like creating a storage account or creating the virtual network, and leave the other pieces out. And the other part is you can also leave the NVM configuration in a separate template. You can actually go define a template that just is responsible for deploying the app and configuring the app, let's say MongoDB or other apps, right? So you can keep a separate template. And obviously, the multiple Azure resources, like for example, if you're doing websites or SQLDB, keeping them in a separate template is good. Now, you've gone ahead and created 5 or 7 different templates now. How do you go and patch them together? So we have the capability in the platform called template linking, and I'll show you a sample of that. It is actually going to go ahead and allow you to stitch all of these different templates and express dependencies between them. Now you can express dependencies between the not just the infrastructure, but you can also express dependencies between the NVM aspects of it. When you think about the NVM configuration, what I need to do inside the VM, always think about architecting in a way you take out and break apart the common scripts that you need to run across a bunch of nodes and actually have separate scripts for that, and then do the app-specific scripts as well. So if I were to just think about this and look at, try to put an architectural diagram around it, what you will have is you have to define the set of parameters that you want to place or accept in your template across different environments, dev, test, and prod, and then have a master template that is responsible for actually going and deploying the whole app, but knows how to call into the right set of apps and the dependencies. And I'll show you some samples for that. And have some logic or strategies for how you would place or accept inputs from the user that targets different environments, dev, test, or production. And then have these different member resource templates or shared resource templates. When I say member resource, these are templates that would be responsible for deploying the actual VMs and stuff like that. But the shared resource templates more are around the infrastructure and the storage accounts and things that you need to go create. And in other cases, the shared resource could also be a website, right? And then you can actually have a simple template that is responsible for spinning up a single VM, and you can go ahead and use the looping capability to call it again and again. So you can accept a user input which says, spin me up 7 VMs in a DataStax Cassandra cluster, but then actually have a single VM setup cluster and then call it again and again 7 times to actually go spin it up on the fly. So you can architect this entire app from a single template file. And then from the template file, you can choose to call into the different extensions or the scripts themselves and say, hey, go call one of these basic scripts that will just first pull down the MongoDB or the Cassandra database specific exes or tar files, and then run specific scripts to do configuration based on the input that you have passed in, for example, for the data side. In some cases, the shared resource templates could also choose to be called into the script files themselves. So in this example, what I'm going to do is I'm going to talk a little bit about a real-world app which we have built, and it's available for you guys to go try, is the DataStax on Azure Virtual Machines v2. So DataStax is an industry leader in developing and delivering solutions based on Apache Cassandra, right? And they have 2 SKUs available. They actually have a community SKU available. They also have a DataStax Enterprise SKU available for you guys to go use. And they're a commercial enterprise-ready NoSQL database, right? So we have quite a few customers who have already started using Cassandra on Azure. So what we are going to look at is how do we go spin up this entire cluster in Azure. We're going to look at how you can have this front end or the Ops Center VM, and then you can specify or accept a set of input nodes or input VMs from the customer and be able to spin up the entire DataStax Cassandra cluster. Okay. Here's a quick view of what, when I walk through the template or when I go to the folder, you might see a bunch of these things. I just want to give you a perspective. When we talked about the master template, that's the Azure deploy.json. When we talked about, breaking apart the different pieces, you could think of the Cassandra nodes themselves. That could be the ephemeral nodes.json. You actually have a file that defines that specific configuration. You have the Ops Center VM with which you actually log in and monitor the entire DataStax cluster. That could be a separate, JSON file. We've also broken down the installation of the configuration of the Ops Center VM as a separate JSON file. So the extension, the script running inside the VM to configure Ops Center is a separate JSON file. So you can actually break all of these different files and the scripts themselves to go ahead and run. So let me go ahead and switch over. Hit 8. Oh, so the earlier demo that I showed succeeded, and the important part to note here is that if you actually see, we started at 111, about 115, 4 minutes, you get 20 virtual machines, which is phenomenally different, right? So, all right, let me jump back. Let me go here. Okay, so if you look at it, here's the entire set of files or folders that, files that actually constructs this DataStax template. So as I mentioned earlier, we have a Azure deploy.json, that's your master file. And then you have the ephemeral nodes, which is the specific nodes that are the JSON files that are used for spinning up the DataStax nodes. And then you actually have the Ops Center resources.json, which is actually the Ops Center configuration of the VM. And then you have the Ops Center install resources, which is running the custom script extension inside the virtual machine to configure Ops Center. So if you look at this template, once again, very similar. You have the parameters section. And another important part here with this template specifically is that it accepts the cluster node count. This is the number of nodes that you want to specify in the Cassandra cluster. So it's very similar to the other template that we used, but here we'll be using a different strategy for actually going ahead and deploying such a complicated app. So let's go back in here. The first thing that I want to point out to you guys here is the resources section. We have a model, I talked about how you can actually have different templates. We have introduced this model where you can have template linking capability, this thing specifically here. This template linking capability is what allows you to stitch all of these different templates together to go build the right set of app, right? So you can pass in the location of a template link here and say, hey, here's the location for this particular deployment, which is the first one here is the shared template URL, which it means that it's going to spin up the virtual network and the storage accounts. It's actually setting up the environment, setting up the basic infrastructure, and it's starting from there. So that's the first template, first deployment that's being executed. The second deployment here is the cluster nodes. You're actually triggering the deployment of the cluster nodes specifically. You're creating, let's say we start with the DataStax Cassandra cluster for 5 nodes or 7 nodes. Those are the nodes that will get created next. So it's the cluster nodes template URL, and that gets created. And if you look at it, it actually accepts the node count information. So it gets passed in, so 5 or 7 or 10. It accepts that input and actually goes ahead and creates so many other nodes. And if you look inside that template, that is actually going to create one virtual machine with a copy having 7 or 5 being passed as an input, right? And the last section is the Ops Center thing. So let me go back here. So this is the Azure Quick Start template section that I talked about earlier. So this is the announcement that we have made. If you actually go to azure.com, go to community, and then go to the template section, you will actually land here. These are the different templates that I talked about earlier. So we have about 60 or 70 odd templates and very application-oriented templates as well. So we have Kafka, Spark, Hortonworks, Cloudera, DataStax, all of these different templates available on the platform. So let's go pick DataStax and Ubuntu. So right from azure.com, you can actually go ahead and deploy this template into your subscription. So you can actually go say deploy to Azure. what this is going to do is it actually is going to take the Azure deploy.json file, and it's going to take it into the portal.azure.com, parse the file, and allow you to edit the parameters and actually go deploy this right into your subscription. So that's what you're seeing. So now it is loading the whole template into the portal, and it's going to generate a custom UI for you. It's actually going to take, based on the number of we looked at, like, let's say, all of these different parameters that we are looking at here will now be loaded up here in this template file, and it'll actually allow you to edit this file in a single click. Let's give it a minute. Yep, so that template file is now directly loaded into the portal from a single click, and you have the flexibility to go enter the values for this. So this is the entire template file that we just looked at, and it actually has all the deployments. I'm going to just go ahead and save it. I'm going to edit the parameters. Just go get stacks, 67. Just go use that name. I'm going to go ahead and give it some parameters. Pick D3. I'm going to spin up a 5-node cluster. Give it a cluster name. I picked an existing subscription. I'm going to create a new resource group. Let me pick West Europe as the resource group location. Just back. West Europe. Okay. And go create. And this is it. So deploying data stacks on Azure, which used to be such a long process, is fundamentally simplified for you, where you can just go from any of the existing templates and you can just go start creating that deployment, which was not possible before. So that's what we've done. So let's give it a minute. I'll go back to show you the progress of the deployment, but given in the interest of time, I already have a DataStax such a template that I've already deployed. So I'm going to go just zoom in a little bit. The same 5-instance deployment that I had created, you can actually see the 6 virtual machines here. There's 5 DataStax nodes and 1 Ops Center node. And I'm going to just point you to here's the Ops NIC, right, the network interface for the Ops Center VM. And if you look closely, here's the public IP address for that VM, and I'm going to navigate to show you the exact DNS name. So this is the DNS name that we are going to log into and look at the DataStax configuration. So this right here is that location. So it's DataStax cvg6.westeurope.cloudapp.azure.com. And with a single click, what you got was a 5-node DataStax Cassandra cluster in just less than 15 minutes, which was not possible before. So that's the power of the single node, the Azure Resource Manager integrated with compute. And you can look at the nodes. You can actually look at what's happening in each one of those different nodes, what's the running tasks. All of this is possible with just a single click. All right. Why don't we switch over? Cool. So just kind of wrapping up, the last part about this is all of these templates and the language that we talked about, the APIs themselves, not just more on the template side, but also the APIs themselves and the client tools and the Azure PowerShell commandlets. All of this is going to be consistent. When I say consistent, this is a single unified Azure API stack that is going to be shipping with on-premise as well. So the amount of the effort, the code, any apps that you build or write on top of the APIs for the V2, IaaS V2 stack is going to be consistent. So the same APIs will actually work against an Azure on-premise endpoint as well. And I'm going to give it back to Boris so he can actually do a quick demo.
All right. So what do you guys think so far? Is that cool, the new stuff? Cool. All right. So. All right, sake of time, as Mahesh mentioned, by being consistent, we truly mean what you've seen here. You will be able to do exactly the same thing on premises, in your on-premises environment over time. Just to prove the point here that we are not just making that up, I can show you work in progress right now. Switching back to 5. So, again, this Visual Studio, I know it's hard in an IS session to look at Visual Studio, but it gets the point across, I think. So if I want to start with a new template, I could do that here, hopefully. And I click Azure Resource Group. And now you can think about, you get this template selection, and as I mentioned, we'll integrate with GitHub, so you will be able to pull it down from GitHub or from any other repository. So let's check the virtual machine template for now, just a very simple one. And what you'll get is basically a project I was showing you before with a SharePoint template. But the biggest difference, and again, that's work in progress, the biggest difference now is that if I'm going to go in here, so here's my template, just to set. This is the template. Now if I come in here and say deploy, create a new deployment, so it sees my account. I'm signed in with my bScholl account, but it also knows I have a on-premise Azure environment. So I can come in here and say, hey, which cloud do you want to deploy that thing to? Do you want to deploy it into public Azure, or do you want to deploy it into the private cloud? So here I'm going to choose private cloud. And then it lists my subscription. It knows. It's actually pretty cool, I think, because I'm signed in with my AD account. It knows that I have access to private cloud. It lists the environments I have access to. And then it lists the resource groups. And again, there is no resource group in there right now, but I think you get the point. So eventually, at some point, you will be able to take that very same template and just decide which environment you want to deploy it into. And I think this is a really, really great story we have here. And with that, that was really a very short demo, but we just wanted to prove the point that we're really working on that. So, you want to close it?
All right, cool.
Cool.
All right, so in closing, I think we wanted to get you guys ramped up on the new IaaS v2 stack, some of the improvements and the advancements made, not just the fact that it has come under Azure Resource Manager, but also there have been fundamental improvements and features that have been added. We've gone back, thought a little more about the networking constructs, went to the fundamentals, broke it down, made it Lego blocks, and we've added more capabilities around VM extensions and how it integrates with Resource Manager, so you can actually go build an app. Think of apps more than the infrastructure. That was the goal. All right? Thank you so much for your time.
Thank you, guys.